In a previous video, which I've linked here and below, I showed you how to use an O.MG cable to capture the Wi-Fi passwords from a laptop. I demonstrated how I could send keystrokes to a laptop using one of these O.MG cables and get that laptop to send all of its passwords, so all the SSIDs and passwords, to a server hosted on the internet, or in my example, a Kali virtual machine running on my Mac. Now, a lot of you asked me how I did that. So in this video, I'm going to show you step by step how to set up an O.MG cable. Now, let me warn you, this is going to be a very technical video. I'm going to be going into a lot of detail on how to set up these O.MG cables from zero, basically, to a working payload. In other words, how to run a payload and launch an attack on a Windows device, as an example. You don't have to use these just with Windows devices. You could use it with a Mac, as an example. Just depends on the payload that you run, depends on the attack that you want to run. But please note, this is going to be a technical video. It's going to be detailed. I'm going to be running a Kali Linux server here. I'm going to be running a Python web server. I'm going to be programming these cables to launch payloads. Now, again, it's a fairly technical video showing you how to set these up. So it's going to be quite a long video. You might want to use this menu to jump to a specific topic of interest, or use the menu below. So if you've already got the cable flashed, you might want to jump to a different part of the video. But I'm going to show you all the steps. When I purchased these cables originally, I found that there wasn't much documentation online showing you all the steps. So I'm going to show you from basically, you get the cable, how do you set it up from beginning to end. And I'll show you all those steps. Okay, let's get started. You can purchase the O.MG cables from Hak5. There are various cables, such as a lightning cable that I demonstrated, so lightning to USB-A. There's a USB-C to USB-A, micro USB to USB-A, and you've got a cable programmer. Now, in this example, I've got the USB-A to lightning cable. This is the cable that I demonstrated in my video. So I plugged this into a Windows laptop and manipulated the Windows laptop. This cable impersonates a keyboard and sends keystrokes to the laptop pretending to be a keyboard. And that's how I managed to manipulate the laptop. The lightning connection to the phone is just a decoy. I wasn't doing anything on the phone. A lot of people said, but David, I would never charge my iPhone on a Windows laptop. I wouldn't plug my iPhone into a laptop. That was just a decoy. The manipulation or the attack was done using the USB side of the cable. Now, you may not decide to use an iPhone cable, but notice in this example, I've also got a USB-A to USB-C cable. So this cable could also be used to launch the attack. Some people have said, well, David, does it only apply to Windows computers? And the answer is no. These cables pretend to be keyboards. So they send keystrokes to a device, which could be a Mac, could be a Windows computer, pretending to be a keyboard. This is based on the original work done with the USB rubber ducky. I'll demonstrate the USB rubber ducky in a separate video. The USB rubber ducky, as they say here, looks like a thumb drive, types like a keyboard. So pretends to be a keyboard and will send keystrokes to a computer pretending to be a keyboard. Keyboards are often trusted. So when you plug a keyboard into a laptop or a computer, that device is often trusted, and the keystrokes sent from these cables are trusted. One of the things you will need to buy is the programmer. You need the O.MG programmer. You cannot program these cables without the programmer. When they arrive, they don't support access point mode or AP mode. You have to configure them to run as an AP so that you can connect to the cable using another device and control the device remotely. So you need to have both the programmer and the relevant cable that you want to buy. So maybe you want to have the USB-A to USB-C or the lightning cable, etc. So from a purchasing point of view, you need to have at least one of these cables, and you need to have the programmer device. I'll once again demonstrate the USB rubber ducky in a separate video, so we won't concern ourselves with that now. But please note, the O.MG cables are based on the USB rubber ducky. So the commands used on all of these cables is the same. So once you can program the USB rubber ducky, you could program the O.MG cables and vice versa. So I'll spend some time showing you the various scripts. We'll start with a very basic script, and then I'll show you more advanced scripts. So again, jump to the relevant point in this video if you want to skip some of the basics. I'm going to use this USB cable because it's a brand new cable. No configuration has been done on this cable yet. I've previously configured this lightning cable with payloads and scripts, so that's already been configured, so I won't use that cable. I'm going to use this USB cable. Now you need to plug this into the programming device, so into the programmer, and there you go. And then you need to put this into a laptop to do the configuration. Now for this demonstration, I'm going to be doing everything on this Windows laptop. Most people use Windows laptops, so I'll use that for the demonstration. But it still works if you want to use Mac OS or if you want to use Linux. So I'll plug this into the Windows laptop, and then I'm going to remotely control the Windows laptop from my Mac. Just makes it easier to do the recordings. So all I need to do is plug it into the USB port on the laptop. Now that it's plugged in, I can go to the URL on the packaging. So the URL that they give us to configure the device is https O.MG LOL setup. And then we asked to select our cable type. So there are different types of cables, including a malicious cable detector. A number of people have asked me, so how do you stop this nonsense? I noticed there is a cable that they're producing to stop this kind of nonsense. So I'm going to select the O.MG cable, and that takes me to GitHub. So here's the link on GitHub to get the firmware. This was last edited about 14 days ago at the time of this recording. And we told a little bit about the cable, that it acts like a normal cable down to the millimeter, so you wouldn't visually be able to see if there's any difference between this cable and other cables. It behaves just like a normal cable, supports high-speed data transfer, supports charging, etc. But, and this is the important piece, is that it allows you to perform keystroke injection attacks using an 802.11 wireless interface. So again, it supports Ducky script payloads. So if you have a rubber ducky, same kind of scripts are used. Okay, but that's enough of the documentation. First thing we need to do is flash to the latest stable firmware. So I'm going to open up another tab to go to that link. And this was released about 8 days ago. So I'm going to get that latest release of firmware, 1.5.2 in this example, and save it to my local hard drive. That's about 27 meg in size. So I'll open that up. So here's the zip file. And what I'll do is extract the contents to my downloads directory. Okay, so we have two directories now, Mac OS, or this directory. I'll take this because I'm using Windows. And notice there's a flash Win64 executable. In the documentation, we told that most computers will require a driver for the programmer to be detected. I didn't have to do that, so it was automatically detected by my computer. But they do recommend that you install it. You need to plug in the programmer to the computer and plug the cable into the program, which I've done, and then run one of these flashes. So you can use the Python script, the official flashing utility. So if you've got Linux, you could just use that. You do need Python 3.7 or higher. You can use Flash. These are pre-made binaries for convenience. Most, but not all environments should work fine with these. If you have issues, use the flash.py flasher. That software has worked well for me in my previous testing, so I'll run that. Double-click on the flash.win64 executable. Windows complains that I didn't get the software from the Windows Store, but I don't care about that. I'm going to say install anyway, and then I'm going to say yes to run the software. And notice what it's doing. It's detecting the serial port that the cable is connected to. So scrolling up, we can see the firmware version. We can see that updates are available on GitHub. It cycles through the various serial ports, and then it connects to the cable. And then it says flash operation complete. Now you need to choose which Wi-Fi mode you want. In my example, I want it to act as an access point. You won't be able to connect to the wireless access point on the cable until you configure it as a wireless access point. And that's what I demonstrated previously. That's probably what most people want to do, but you can use it as a station. So I'll press enter there. Wi-Fi ID I'll set to FBI like my demo, and then I'll just set it to secure FBI 123. And what I'll do here is just take a copy of that so that I remember what I set it to. You're obviously going to want to use something more secure than that, but that's what I'll use for this demo. Press enter, and as you can see, patch success. Everything looks good. Writing to the cable. All you need to do now basically is wait for the cable to be updated with this utility. So just give it a little bit of time to update. And there you go. We're told that operation has been completed. We can see our details once again. So I'll copy that to Notepad just to have a backup. And then we're told that process finished, remove programmer and press enter to continue. So I've removed the programmer from the laptop, and then I can press enter to continue. Okay, so cable has been updated. And now we're told to connect to the O.MG cable web UI. In station mode, you do it that way, or in access mode, you connect to this IP address. So I'll connect the cable again without the programmer. So on my Mac, I can search for Wi-Fi networks and I see the FBI network. I need to put in my password. So secure FBI 123. Obviously not a very good example, but there you go. And it's trying to connect to that network. And there you go, I've connected. So now that I've connected to that network, I can browse to 192.168.4.1. So what I'm doing now is I'm connecting to the Wi-Fi network on that cable from my Mac directly. So through Wi-Fi to that cable. And I could do the same with an iPhone. That's what I demonstrated in my previous video. But in this example, I've simply connected through my Mac. Okay, so now it's time to have some fun. Let's start with a very basic script. In this example, this script is simply going to open up Notepad and write something. So I'll copy the script to the O.MG cable. I'll paste it in. What I'll do is save the script. You don't have to save the script, but it does make it easier if you're out in the field and you simply want to launch a script very quickly. Rather than trying to paste it in, it's ready to go. And what I'll do now is run that script, and what we should see is something happens on the Windows laptop. And as you can see there, Notepad opened up and some text was written. Very basic example. So basically, the O.MG cable is impersonating a keyboard. It's sending keystrokes to the computer, impersonating a keyboard. Okay, that was very basic. Let's do something else. So this script here, and by the way, I'll put all the links to the scripts below this video. You can get a lot of these scripts if you search for Rubber Ducky scripts, or have a look online, but I'll put some links to the scripts that I used as the basis for what I'm doing here. A lot of other guys have done the hard work, and I've simply taken their scripts and then edited them to make it easier to use. This one will open a browser and get the computer to browse to a certain website. Now, one thing I'll tell you is that it loses connection to the wireless network when you run a script. So on your computer, you might have to connect back to it. So I've connected back to the O.MG cable, and you'll get something like this. So what you might have to do is just make sure that you've connected back to the Wi-Fi network, and then you need to refresh your browser. So I've had to open another tab here to get it to work. So just be aware that you lose your connection to the cable when you run a script. You just have to reconnect. So I'll paste my second script in. I'm going to save that to slot 2. So that's been saved. So basically what we're going to do here is run Chrome and then get it to browse to a specific URL. And then I'm going to use F11 to make it full screen. So I'll click run. And on the Windows laptop, we should see that Chrome opens up. And there you go. And that the URL is selected and that the screen is put to full screen. I've stopped it being full screen, but there you go. I've managed to get it to open up a web browser and browse somewhere. And that's really important because I can get it to browse and download malicious scripts. I'll show you that in the Rubber Ducky demo that I do, where I will get the computer to download stuff and I'll take remote control using a reverse shell on the computer. But I'll show you now how I managed to get the computer to send me all the Wi-Fi passwords as I demonstrated in this video. Okay, so to get the computer to upload all of its Wi-Fi credentials to a web server, I need a web server somewhere that can accept put commands. This is a simple Python script that allows me to run an HTTP web server that once again accepts REST put commands. I'm basically going to use REST commands to get the Windows laptop to put its configuration on a web server. So I'm going to run this simple web server and I'm going to run it on port 80 rather than port 8080 as they've got it in this example. Again, the scripts to all of this stuff is below this video, so use the GitHub links to download the scripts yourself. So to run that, I'm going to use sudo python simple HTTP put server, and the port number that I'm going to use is port 80. So that server is now running. I'll open another window. IP address of this server has been manually configured as the following: 192.168.1.239. But what I've done is I've set up a DNS server locally in my network to map the domain name, the boss.lol, to that IP address. So on the Windows laptop, as an example, if I open a command prompt and I ping the boss.lol, notice it resolves to that IP address, 192.168.1.239, which is my Kali Linux server. Now I'm running a Pi-hole server as my DNS server locally here. So all my devices are pointing to this DNS server, which allows me to block malicious domains and advertising and whatnot. So under my local DNS records on the server, I've mapped that domain, the boss.lol, to this IP address. Now on this laptop, the DNS server is configured as that Pi-hole server. So if I look at the wireless configuration of this laptop and look at IP version 4, notice this is the DNS server. DHCP in this network is allocating that as the DNS server. But if you resolve that domain name, I actually own that domain name. So you could just register a domain name and then point it somewhere so to apply publicly. I've just done that locally in my local network, but the boss.lol is actually my domain name that I registered, and I could point that anywhere. I've just done that so that people don't try and copy what I've done here. So this device is going to send the Wi-Fi information to the Kali Linux server and put that in a temp file. Now, this script I got from GitHub. It's a Rubber Ducky script. It's basically going to run PowerShell, and it's got some delays here, and then it's going to use PowerShell to get all the pre-shared keys and export them into a directory. So they're going to be put into this temp directory, and then that's going to be copied to the web server. So I mean, I could copy this entire script. Rem is just comments, so you could get rid of those. I'll connect back to my O.MG cable and then open up a browser. I'm using Brave here, so that sometimes causes problems. But basically, I can paste that script in. I'll save it to slot 4 here, just to be consistent with my previous video. But there's the whole script. Now let's see it work. So I'll run the script. And what we should see is something happens on the Windows laptop. Okay, so Windows did something. Something happened. User's not quite sure what went on. But the important piece now is on my Kali Linux server, we can see that something happened. So something happened here. A Windows device connected to our server. And in Kali now, type ls, here's the temp directory. And if I unzip that temp directory, there are all my Wi-Fi passwords on that laptop. So all the Wi-Fi passwords from that laptop have been copied here. And if I cat Wi-Fi, my secure Wi-Fi network, there is the SSID and there is the password. Now, just in case you don't believe me, I'm going to remove all the XML files and I'm going to remove that temp zip file. So previously I had all these XML files and the zip file, but they are all gone now. So ls shows me that those files don't exist. And what I'll do is connect back to the O.MG cable. So go back to the FBI network. And what I'll do now is run that script again. Okay, so we've connected. I'll load the script stored in slot 4. And then I'm going to run it. And hopefully what we should see is something happens on the Windows laptop. And there you go. Commands are being copied to the Windows laptop. And now the information is being copied to my web server. And then the script deletes the information and shuts the PowerShell down. So the user doesn't realize what's going on. And back in Kali now, notice ls shows me the zip file is back. Unzip temp.zip. There are all my Wi-Fi networks. Cat Wi-Fi, my secure Wi-Fi. There's the SSID. There's the password. Okay, so that was quite a long video, but I've shown you all the steps now. How to go from 0 to a working O.MG cable. How to send commands to the O.MG cable to get it to do things. Very basic scripts initially, but then I showed you a more advanced script where we could copy all the Wi-Fi passwords from a Windows computer to a server, somewhere on the internet if you like. Now some guys have asked, okay, what about antivirus? You can bypass a lot of the antivirus through this because this is emulating a keyboard. An antivirus will normally accept keystrokes from a keyboard. The cable, and the same is true for the rubber ducky, these are emulating keyboards. They are pretending to be a keyboard. They are basically automating keystrokes. So a lot of antivirus will accept keystrokes. Now there are some cases like with reverse shell where it won't allow those kind of connections. It will think it's a hack. But a lot of the standard stuff like copying files to an internet server is seen as normal behavior and that would be permitted. But let me know, did your antivirus block this? What is your experience been? What have you had to do to get this to work? Hope you enjoyed this video. If you did, please like it. Please consider subscribing to my YouTube channel. And please click on the bell to get notifications when I post a new video. I'm David Bombal. I want to wish you all the very best.